Okay, so make the project number 17, Network X. And put the label the graph concept. Number 2, weighted graph. Number 3, animated. Number 4, social media. And here you type the PIP install NetworkX, and then import the network X as NX. Okay, and then run. Okay, so it's installing all of the package. This is typo, the graph concept. Okay, and then we make our first code. G is the NX. Okay, so from this NX, okay, you put the NX here and then the graph. And then first we add the H from A to B and from B to C and from the P to Q. And then the NX, NX draw the graph. Then you can run. This is the result. So we have the result like this. Okay. Okay, so from this image, actually, we can identify that this should be a P and Q here. Okay, because P and Q is not connected to any other, but A and B, B and C. So from A to B, from B to C. And this below is the A, B, C. A to B and B to C. And this is the node, and this is the H. So the node, this is the node. Yeah, this is also the node. This is also the node. And this is the H. H is the link or the connection. Now, so we can make the definition of the graph. So graph is constructed by nodes and edges. Okay. Node is a representation of entity or object. A node is a representation. An object or an edge is a connection between two nodes. like break here. Okay. Okay, let's make a new cell. So you make a graph. Can be graph 2, which is from NX graph. Okay, so graph 2, you add H, A, B. Sorry, this is graph underscore W with the weighted graph. So A, B, B, C, you can put properties as the weighted one with. So the weight is 1, maybe 2, or 3, maybe 2 or 5. And then you can run. Okay, so this is with the property with bobot. Nah, so you draw with label, with label, true. So you have the labels representing what note, what the note is. Okay, or with label. So A, B, C, and then this one is the P and Q. So you make your new code a cell. So you can make a list from the graph, and then you run. So we're gonna have the nodes back with the weight that it has. Retrieving the nodes from the graph. So you make a new code here, retrieving the weight. So you can go into the graph, take the H, okay, this way can, or you can also make all, because this is list of the list. So you have the value of A and B, the weight is 1 here because we declare when we define the weight is 1. You can also change this to the Q. We have the 5. Or maybe Q to P also can. So with one first, doesn't matter, yeah, the which one of the note that you write first. Okay, so I put label. So the weight indicates the strength of connection between two nodes. It may reflect the similarity between them. such as maybe their hobby, or maybe their score, or maybe their sport intention, or maybe they are spending e-commerce, etc. Okay, so we continue. Code. Okay, we make a graph D is a D graph. Okay, so we add A, B, A, B, and then the A to D, and then A to C, okay, together with their way. Yeah, say this one, and then you add the edge between B and C. Okay. So actually, you can draw the graph by calling this with the label, yeah, and X draw, run, and you have the label there. Make the post an X spring layout. Okay, and then you can run. And then NX draw network X nodes. GD position. Okay. And then you draw the edges position and then the labels position. Okay. You can always run the code. Okay. So this is the directed graph. Okay, ini graph berarah. So ada arahnya ditunjukkan oleh panah ini. Okay. So when you make A, B, so it should be the A to B. Yeah, because AB. So this is AB. AD. So there will be D. And from A also pointing to D. So AC from A is pointing to C. BC, so from B to C. Okay. So ini tadi kita bikin hujan bisa mengakibatkan banjir, bisa mengakibatkan macet, banjir bisa mengakibatkan macet, banjir bisa diakibatkan oleh got yang mampet. Nah, jadi ketika ada kemacetan terjadi, maka penyebabnya mungkin hanya hujan atau banjir. Either dia hujan atau dia banjir. So, ketika ada macet, ternyata hari itu tidak hujan, maka bisa disimpulkan bahwa ada banjir. Loh, kenapa bisa banjir? Kan tidak hujan. Oh, berarti ada God yang kemarin mampet lagi. Nah, ini kira-kira ada hubungan yang bisa digambarkan, diilustrasikan dengan menggunakan model graf seperti ini. Okay, so okay, let's remove this. Okay, and then run. Okay, so you remove this, you run. So this is the value of the A, B. So every time you run, the value will be changed because the position will be re-render again. Yeah. So this time C is here, but when you run, C is going there. When you run, the C is there. Okay, so this is the current position that the graph has about certain nodes. Okay, challenge. Yeah. So Agus, Budi, Charlie, Doni, Emma, uh, Ando, Gordon, Uma, Irma. Okay, so Agus has follower Doni, Emma, Uma. Budi has follower Charlie, Gordon, Uma, Irma. Okay, so we have the Doni and Huma are new member, so they don't have follower. Emma has follower, Agus Charlie, Fando has follower, Doni, Uma Irma, Gordon and Irma. Irma does not have follower. Okay. Okay, so we can make a graph with the uh, follower. Okay, so we can add Agus, Doni, Emma, and Uma. Okay, so we can make Agus, Doni, Emma, and Uma. Okay, and then you can draw using this, you can draw the uh, okay, but there must be the graph. So better the graph with here. Um, okay, you can copy from this, copy. Okay, then you can run. Or maybe like this. Yeah. So Agus has follower Doni. So Doni, Emma, Huma. So should be Doni. Yeah, we have Emma, Huma. They should follow Agus. So should be this connecting follow. Yeah, because follower. Agus has followers. So Emma, Doni, and Huma is their follower. Okay, however, the result here, Agus, the R is going out to D. So we should do in a reversal way. Okay, that's why this should be Agus on the left, okay, and Doni, Emma on the right. So you can change this, yeah, and change, remove, put Agus here. Okay, so Agus, okay, then you can run. So let's see from Agus to Tony. Oh, sorry, so GF here. So should be a GF. I forget to change. Oh, GF post. GF. Okay, you run. Okay, so Agus already in the center. Agus followed by Emma, followed by Doni. Okay, so you have to adjust the position of each nodes. Okay, so yang ini saya tutup saja. Close this, you run. Okay, so Agus has 3 followers. Okay, so now good. We continue with Budi. Nah, Budi followed by okay, ya, Budi. Okay. 1, 2, 3, 4. Okay, 4 member. Okay, so Budi followed by Charlie, Gordon, Uma, and Irma. Okay, you can run the code and you're gonna have a growing one like this. Uma here. So Huma so far is a follower, yeah, because Huma is not followed by any member. Okay, continue to the Charlie. Okay, so we can make Charlie here. So Charlie, yeah, Charlie followed by Doni and Emma. Okay, the network is growing. Yeah, you can re-render again. Nah, so more crowded, yeah, more crowded the network. So when you see here that Agus still has the most follower, Charlie 2 follower, but Agus has 3 follower. Budi, okay, Budi 1, 2, 3, 4 follower, Budi. Okay, and can continue to the next. Gordon followed by Huma. Okay, so we have all. Irma does not have follower. Okay, so we can draw the network now. Okay, so this is the network. Okay. So if you have this visualization, this is very, very helpful. So you can look up the degree of nodes degree. So the nodes degree, you can count degree. Yeah, so how many for this? 1, 2, 3, 4. So the 4 will be the degree for Budi. Of Fando, it has 3 degree in and 1 degree out. This 4 and 1 out. So no, so Budi is not following any of member. Irma, Irma 0 and no follower but following 2. Okay, Charlie, 2 follower following 1. Yeah. Emma, 3 follower following 1. Agus, 3 follower following nobody. Okay, so based on this, you can count the degree. So based on the degree, you can calculate easily which member has most follower. Okay, which member has the most follower, or which member follows most friend, the most friend. Okay, you can easily calculate because you have the network. Yeah. Compare to the data set that you have many lines, you have to count the frequency. It's gonna be very long. Number one. Okay, so this is the number one benefit of having the network. Number two, you can see the similarity in between. For example, should we connect Agus and Budi? Currently, Agus and Budi, they are not connected, okay? But should we connect them based on their pet? So they have Emma and they have Charlie. So Agus and Budi actually are connected between another two nodes, okay? Okay, number one. So we can compare, should we connect Fando and Budi? So based on this, we can see that Fando and Budi, they have Gordon connect between them, and they have also Huma. They are connect, the connection between them. We call them as the common share nodes. So they share the nodes between them. One, Gordon, they share. Huma also they share. Any other? I think Gordon, Huma, and Irma. Also they have Irma. So it more likely that Fando and Budi should be connected rather than Agus and Budi. Yeah. So Fando and Budi more, yeah, are more likely to be connected. Uh, then, then Pando and Agus. Okay, more likely to be connected. So Fando, Budi, okay, are more likely to be connected than Agus. Oh, sorry. Agus and Budi. Yeah, Agus and Budi. Sorry, so I changed this. Should be Agus and Budi. Yeah. Then Budi and Agus. Okay, so once again, this to be, they have more similarity about the share notes friend. Maybe they are from the same class previous years ago, so their friends are actually the same. Yeah, but with Agus, actually kind of a long stage here from Emma to Charlie to Budi. Yeah, their friend of friend are connected, but there is no direct friend in between them. Yeah. So that's why there will be suggestion, Fando, maybe you like to connect to Budi, or Budi, maybe you like to connect to Fando. Okay, this is the end of our the graph introduction.